Hello friends, this is Vinay from iOS interview. Today we will discuss about ARC and return cycle in Swift. So friends, this is very most important topic generally asked in iOS interview questions. So friends, moving further on the video, if you did not subscribe my channel till now, then please subscribe and press the bell icon. So moving on the video, the only way to do great work is to love what you do. This is quote by Steve Jobs. Topics we will cover on this video are introduction, how ARC works, strong, weak and unknown references, return cycles and memory leaks, ARC enclosures, example of return cycle by using URL session and conclusion. Introduction. Automatic reference counting ARC is Swift is a crucial feature for memory management. It automatically manages the memory usage of your application, ensuring that the memory used by instances of classes is freed when those instances are no longer needed. Understanding how ARC works is key to writing efficient and bug-free Swift code. How ARC works. Number one, reference counting. ARC tracks the number of references to each class instance. When you create a new instance of a class, ARC allocates a chunk of memory to store information about the instance and sets an initial reference count to 1. Number two, incrementing and decrementing reference counts. Each time you assign that instance to a variable, constant, or property, the reference count is incremented. Conversely, with those references are no longer needed, for instance, when they are set to nil or go out of scope, the reference count is decremented. Number three, automatic memory deallocation. When the reference count of an instance drops to zero, meaning no more references exist, ARC automatically frees up the memory used by that instance. Strong, weak, and unknown references. Swift provides several ways to establish relationships between instances affecting how ARC manages memory. Number one, strong references. This is the default when you assign a class instance to a property, constant, or variable. The reference is strong. It increases the reference count and the memory wouldn't be deallocated as long as the strong reference exists. Number two, weak references. These references do not increase the reference count used to avoid return cycles explained below. The reference is allowed to become nil must be declared as an optional, commonly used in scenarios like delegate properties. Number three, unknown references. Similar to weak references, unknown references do not increase the reference count. Unlike weak references, an unknown reference is expected to always have a value non-optional, used when you know that the reference will always point to an instance, yet you don't want to create a strong reference. Return cycles and memory leaks. Number one, return cycle occurs when two class instances hold strong references to each other, preventing ARC from deallocating the instances as their reference counts never drop to 0. This situation leads to memory leaks when memory that is no longer needed is not freed. Breaking return cycles. You can prevent return cycles by defining one of the relationships as weak or unowned. Typically, one of the instances has a shorter lifespan. Example: a delegate, making it a candidate for a weak or unowned reference. ARC enclosures. Closures can capture and store references to any constants or variable from the context in which they are defined. If a closure captures a reference to a class instance, it can lead to a strong reference cycle. To prevent this, Swift offers capture lists. Capture lists allow you to define the rules for capturing references within a closure. You can specify weak or unbound references within a closure's capture list to break potential strong reference cycles. Example. Here is an example demonstrating weak and strong references. Class person, let name string init, name string self dot name equal to name, var apartment dnet print name is being deinitialized. So this is another class apartment. Let unit string init unit string self dot unit equal to unit week var tenant person class dnet print apartment unit is being deinitialized. Var John person equal to person name John. Var 4a inherited apartment equal to apartment unit 4a. John force unwrap dot apartment equal to unit 4a force unwrap dot tenant equal to John. John equal to nil. John is being deinitialized is printed. John unit 4 equal to nil. Apartment 4 is being deinitialized is printed. In this example, the tenant property in apartment is a weak reference to avoid a strong reference cycle between person and apartment instances. Understanding ARC is functional in Swift programming as it helps you manage memory efficiently and avoid common pitfalls like memory leaks and return cycles. Example of return cycle by using URL session. To avoid a strong reference cycle when using URL session with a completion handler, particularly in a method of a class where self is referenced. You can capture self weakly in the closure. This ensures that the closure does not keep a strong reference to the instance of the class, allowing it to be deallocated properly. Here is an example. Example class with network request function. Import foundation class my network class var some property string equal to hello. Func fetch data from URL completion address escaping data URL response comma error return void. URL session dot share dot data task with URL weak self data response error in guard let self equal to self else handle the case where self is nil if needed return. Use self here without causing a strong reference cycle. Print self dot some property. Return the results via the completion handler. Completion data response error. Resume. Deinit print my network class is being deinitialized. Usage. If let URL equal to URL string https example.com, let my network class equal to my network class dot fetch data from URL data response error in process the data response and error. If let data equal to data, print data received data. Parenthesis close, parenthesis close, parenthesis close. In this example, my network class has a method fetch data that fetches data from a given URL using URL session. Inside the closure passed to data task self is captured weakly using weak self. This prevents the closure from keeping a strong reference to the instance of my network class. The guard let self equal to self else return line is used to safely unwrap the weakly captured self. If the instance of my network class has been deallocated, the closure will not execute further, preventing any access to nil instances. Conclusion. This pattern is essential when the closure is expected to live longer than the instance itself or when there is a risk of creating return cycles. such as with asynchronous operations or really or event listeners. It's a common practice in Swift to manage memory effectively and avoid leaks, especially in the context of networking and asynchronous callbacks. In this video, we try to cover all differences on escaping and non-escaping closures related iOS interview. We will discuss other questions in upcoming video. This will definitely help you to prepare for your next interview. Thank you for watching this video. Also comment below if you learned something new here. Thank you for watching. Please like, share and subscribe. Thank you.